A planet is moving along an elliptical orbit is close to the Sun at a distance r1 and furthest away at a distance of r2. If v1 and v2 are the linear velocities at these points respectively, then the ratio of v1 by v2 is. So we know that in case of planetary motion, we can conserve the angular momentum, and when the Sun is at let's say Sun is at focus, and the planets are revolving around it in an elliptical path, and this distance is take it as nothing but r1, the minimum distance, and when the planet is over here, distance between Sun and planet is maximum, let's say that is equal to r2. So in this situation it is moving with the velocity v1, and over here it is moving with the velocity v2. Now we can conserve the angular momentum. So angular momentum, we can find out the value of angular momentum by using this equation mvr sine theta. And when it is at the nearest point or the farthest point, the angle made by the velocity vector with respect to position vector is equal to nothing but 90 degree. So we can write at point 1, it is m into v1 into r1 into sine 90 is equal to same thing at point 2, m into v2 into r2 into sine 90. Or you can write it as this, we can cancel this m, sine 90 is 1, so we can write this v1 r1 is equal to v2 r2, or we can say that the value of v1 divided by v2 is equal to nothing but r2 divided by r1.